Hi everyone. By the end of this video, you will have a clear idea on why do we say that motion and rest are relative? What is frame of reference? How do we define that? Then motion in straight line. Then difference between uniform motion and non-uniform motion. Then difference between average speed and average velocity. Then instantaneous velocity. Then what is uniformly accelerated motion? Then as usual, some MCQs, ARQs and some numericals. What do you mean by frame of reference? For that, look at this picture. You can see a basketball player. She is running with the ball and the ball bounces up and down. If you assume a frame of reference, which is a coordinate system, consists of x-axis and y-axis, but to describe the motion of the ball, you don't need x-axis. You just need only y-axis if the frame of reference is attached with the running girl. Which means, if you are running with the ball, you feel the ball is just going up and down. So you need a frame of reference which consists only y-axis and time. But look at the same situation, you are watching it and you are the frame of reference. For you, you feel she is running with the ball and the movement of the ball will be just like this, which means the ball is moving vertically up and it's moving horizontally to the right. You need two axes, x and y, and a timer also. What's a frame of reference? It's a coordinate axis, x, y, and z, with respect to which we describe an event. Here the event is bouncing of ball. To describe the bouncing of this ball, if the frame of reference is attached with this girl, you just need only y-axis. But the same thing, if you go for frame of reference attached with this stationary man, you need both x and y-axis. Why? The ball, for him, he feels the ball is moving right and up as shown in the picture. So the frame of reference contains four coordinate systems: x coordinate, y coordinate, z coordinate and time coordinate, with respect to which we describe an event. Let's do some questions. The first MCQ, a particle in an object is having, of course, negligible size. Negligible size means negligible dimensions. Another question, a rigid body is a combination of many particles, true, and when an external force is applied on it, there is no change in its size, which means again dimension. The third MCQ, rest and motion are dash terms. They are relative and they are not absolute, which means the answer is both B and C. We go for ARQ. A passenger sitting in a moving train is at rest with respect to the co-passengers, but he is in motion relative to an observer standing on the ground. That is true. And look at the reason. Motion and rest are relative terms and purely depends on the choice of frame of reference. That is also true. And the reason is the correct explanation of the assertion. So the final answer is A. We move on to different types of motions. Look at this. Crawling of ant. You can see the ant is crawling in a straight line. So this type of motion we call it as one-dimensional motion or motion in a straight line. Another example, look at the movement of cockroach on a floor. See how the cockroach is moving. Is it moving in a straight line? No, it's moving over a plane and we call it as two-dimensional motion. Why do we call it as two-dimensional motion? To describe the motion of this cockroach, you need x-axis and y-axis. So this is an example of two-dimensional motion or motion over a plane. Now look at the example of a honeybee flying between the flowers. It is not in a straight line. It is not over a plane. It is over the space. So we call it as three-dimensional motion. Then how many coordinate axes you need? You need x coordinate, y coordinate and z coordinate. So we call it as three-dimensional motion. What are the three types of motion? Motion in one dimension where things are moving in straight line. Motion in two dimension where things are moving over a plane. And motion in three dimension where the things are moving in space. MCQs again. How many types of motions are there? There are three types of motions. Motion in one dimension is also called motion in straight line. We move on to rectilinear motion. What does rectilinear means? Rectilinear is a combination of two terms, recti and linear. Recti means straight, And linear means in a straight line. So rectilinear means straight line motion or one-dimensional motion. And the whole unit what we are dealing now is only about rectilinear motion, which is motion in a straight line. For example, the motion of a car on a straight road, motion of an aeroplane while it is moving through a runway before takeoff. We move on to difference between scalar and vector. In physics, we can classify quantities into scalar and vector. What's a scalar quantity? A quantity that has only a magnitude with no direction. Look at the quantities given here. Distance has only a magnitude, 25 km. Speed has 100 km per hour. Time has a magnitude 2 hours. It doesn't say anything about direction. So these quantities we call them scalar, which is only magnitude but no direction. There are certain quantities which have both magnitude and directions. Those quantities we call them vector. Look at this. Someone is pushing with a force of 20 Newton, that is a magnitude, and there is a direction. Displacement has magnitude and direction. Velocity has a magnitude and direction. So these quantities we call them vector. Why do we call them vector? Because they have both magnitude and directions. Now, we go for difference between distance and displacement. Let's see a picture. You can see from home, someone is riding the bicycle to the college. Look at the distance traveled by him, 4 km. He is moving to McDonald's shop, and how much distance he travels? 5 km. How much is the length of the path? 4 km, and another 5 km. That overall makes 9 km is total distance traveled. It's a scalar. We don't say any direction. But displacement means a straight line joining starting point and ending point. How do we find it? You can see here there is a right angle triangle. You know the hypotenuse. You know the one of the sides. And how do you get the other side? C square minus, which is 5 square minus 4 square. That will give you 25. Take away 16, which is 9, square root of 9. So this is just 3 km towards south. So displacement is 3 km towards south. It's a vector. Why is it a vector? Because it has a direction towards south. In this situation, you can see distance is 9 km, but displacement is only 3 km. Displacement is smaller than the distance. Now we go for a situation where distance is equal to the displacement. Look at the initial position and final position. He starts from the house all the way to the McDonald's shop. And how much is the distance traveled? Let me say 5 km. Length of the path, 5 km. And how much is the displacement? Straight line starting from starting point, ending point. That is also 5 km towards east. So in this situation, distance and displacement are equal. This is possible only when the object is moving in a straight line. Now, when is distance not equal to 0, but displacement is equal to 0? Look at the situation. You start bicycling from your house all the way to the McDonald's shop. This is 5 km distance travel. Displacement is plus 5 km, which tells you 5 km towards right. Then he returns back home. Distance travel is another 5 km. So total distance travel will be 10 km. But what about the displacement? Right, you remember, plus 5 km. When he came back, left minus 5 km. So the total displacement is 0. So when will you have 0 displacement? When you come back to the same point, the displacement will be 0. Now, again some questions. The correct statement among the following is, when displacement is 0, distance traveled is not 0. That is true. When displacement is 0, distance traveled is also 0. No way, because distance is more than displacement. When distance is 0, displacement is not 0, not possible. Distance traveled and displacements are always equal. No. So the answer is A. The numerical ratio of displacement to the distance. You remember, displacement is always equal or less than distance. So when you go for the ratio, smaller number divided by bigger number will be always less than 1. And when they are equal, it is equal to 1. So the answer is another MCQ. The total distance traveled by an object from initial to final position is, we call it as distance traveled, path length. Both of them are correct. So the answer is D. We move on to uniform motion. What do you mean by uniform motion? If an object is traveling equal distances, look at this. The school bus travels 10 meter in the first 1 second, another 10 meter in the next 1 second, another 10 meter in the remaining 1 second. What do you see here? Travels equal distances in equal time interval. However small time interval may be, we call it as uniform motion. So in uniform motion, the object travels equal distances in equal time interval. In short, I can say in uniform motion, speed remains constant. Speed doesn't change. Now we move on to difference between speed and velocity. We know speed is total distance divided by total time. Divided by time, we call it as rate. So speed is rate at which the object travels distance. It's a scalar quantity. And look at the equation, speed, distance divided by time, which means speed is rate at which the object travels distance. We go for velocity, which is same as before, but only one difference, rate of change of position, which is a vector, and the equation for velocity equals total displacement divided by total time. See the difference between speed and velocity. Look at this picture. You start from your house to McDonald's. You are moving to the right. How much distance you ride the bicycle? Maybe 2 kilometers. And then what? You are coming back. How much distance you travel? You travel another 2 kilometers. The total distance travel will be, you add them together, 4 kilometers. And let me say the total time, if it is 1 hour, so how will you find the speed? It is total length of the path, which is 4 kilometers divided by 1 per hour, which will give you 4 kilometers per hour gives you speed, which is having only a magnitude, no direction. Now, what about the displacement? Displacement is 0. Why? You came back to the same starting point. And how much is the velocity? Velocity will be 0. Now, some MCQs. Speed is what kind of quantity? Speed doesn't need a direction, so speed is a scalar. Vector needs both magnitude and direction. So velocity is a vector quantity. Assertion reasoning type. The magnitude of displacement for a moving object can never be greater than the distance traveled. True. It can never be more than distance traveled. Why? It is the shortest distance between the two, which will be always smaller than distance traveled. Let us see the reason. That is what the reason says. It is also true. And reason is the correct explanation for that. So the answer is A. Next question. Assertion says, if an object travels from point P to Q and returns back to P, its distance, of course, is non-zero, but displacement is 0. That is true. Now, let's read the reason. Displacement of an object is completely independent of the actual path, but it depends only on initial and final position. That is also true. Now, reason, is it the correct explanation for assertion? No, it is 0. Why? Because it came back to same point means displacement will be 0. So, choices are assertion and reason are true, but unfortunately, reason is not the correct explanation for the assertion. The correct explanation for the assertion is the object came back to the same starting point, which is not given in the reasoning. ARQ number 3, the average speed of an object over a given interval of time is strictly equal to the magnitude of the average velocity. Is it true? No. So, assertion is false. So, the choice is D. The average speed is the total distance divided by total time. It is not equal to the magnitude of average velocity. No, average velocity can be 0. So, assertion is not true. ARQ number 4. An object moving in a uniform circular path has a constant speed. Let's see. Something is moving in a circular path, constant speed, but direction of velocity continuously changes. Assertion is true. And let's read the reason. Velocity is a vector quantity. Yes. In a circular motion, the direction changes at every point, even though the magnitude remains the same. This is also true. And reason is the correct explanation for assertion. So the choice A is correct. We will do some numericals. First question, car moves from the point O to point P. How much time he takes? 18 seconds. And then he returns back to Q. What do they want? They wanted average velocity and average speed for first part of the journey O to P. How do you find the average velocity? Which is total displacement divided by total time. For O to P, the displacement is final position is 360, initial position is 0. So the displacement is 360 take away 0, which is 360. And how much time they took? 18. So average velocity will be displacement divided by time, which is 360 divided by 18 plus 20 meter per second. Plus stands for it was moving towards right. Now what do you want? They wanted average speed. How do we find the average speed? Average speed will be total distance divided by total time. From O to P, total distance is 360. How much is the total time? 18 seconds. So distance divided by time, 360 divided by 18 is 20 meter per second. What do they want? They wanted average velocity. How do we calculate the average velocity? Total displacement. How much is the total displacement? From O to Q, final position, take away initial position, which is just 240 meter. Y positive towards right. How much is the time? The time is 18 seconds to the right until P and then 6 seconds to come back. So total time will be 18 plus 6, which is 24. So the average velocity will be total displacement, which is 240 divided by time 24. So that will give you plus 10 meter per second displacement. Now we go for the distance traveled for the second part of the journey. To get the distance traveled, he went all the way from O to P, which is 360 meter. And then he travels from P to Q. How much is the distance traveled from P to Q? 360 take away 240. So how much is the total distance traveled? 360 and 360 take away 240, which will give you 480 meter. And how much is the time? You add them together, 18 seconds and 6 seconds, which will give you 24. The average speed will be the total distance divided by total time. How much is the total distance? 480. And how much is the total time? 24. So the final answer will be 20 meter per second. Now we go for another numerical. A train of length 100 meter moves with a velocity 72 km per hour. They want the speed of the train in meter per second. How will we change speed of the train in meter per second? Kilometer per hour can be changed into meter per second just by multiplying by 5 and dividing by 18, which gives you 20 meter per second. For the second part, distance traveled is 100 meter and the speed is 20 meter per second. What do they want? They wanted the time, which is distance divided by speed. How much is the distance? 100 meter and speed is 20. So how much time the train takes to cross a man? 5 seconds. Another similar question. Length of the train is 100 meter. Length of the bridge is 200 meter. So how much is the total distance that has to be traveled by the train? Add them together. 300 meter. How much is the speed? As before, 72 km per hour. Change into meter per second. 72 times 5 by 18, which gives you 20 meter per second. What do they wanted? Time. Distance divided by speed. How much is the distance? 300 meter. And how much is the speed? 20. So time will be 15 seconds. Another question. A car travels from A to B one way with a speed of 40 km per hour and returns back to A with a speed of 60 km per hour. They wanted the average speed and average velocity. To get the average speed, we need the total distance traveled. Unfortunately, the question doesn't say anything about the total distance traveled. So what I'm choosing is from A to B, let me assume the distance is x. And from B to A, distance is again x. What we assumed is one-way distance is x. So time taken to travel first part of the journey AB is total distance divided by total speed. Total distance is x and the total speed 40. So this is time taken by the car to travel from only A to B. Now let's find time taken by the car to travel B to A. Distance is same x and the speed 60 km per hour. So it took x divided by 60 to come back. How much is the total time? You add them together. Math, x by 40 plus x by 60. Take LCM as 120. So 3x plus 2x divided by 120, which gives you x divided by 24, the total time taken by the car to go and come back. Now, they want the average speed. Total distance divided by total time. How much is the total distance? One way it is x, return also x. So the total distance will be 2x. And how much is the time? X divided by 24. Divided by x divided by 24 becomes times 24 divided by x. So x cancels. The answer is 48 km per hour. Now, second part of the question, they wanted average velocity. Total displacement divided by total time. Total displacement is 0. Y came back to the same point. So average velocity is 0. Another numerical. 60 km long track. Train travels first part of the journey, which is 30 km, with a speed of 30 km per hour. How fast the train has to travel for the remaining 30 km of the journey to have a total average speed of 40 km per hour. For that, let's see the total time. We know the total time will be total distance divided by average speed. How much is the total distance? 30 and 30, which is 60. And how much is the average speed for the whole journey? 40. So that gives you 60 divided by 40, which is 1.5 hours. Now, let's go for time for the first half of the journey. How much is the total distance? 30. And how much is the speed? 30 km per hour, which gives you 1 hour for the first part of the journey. We move on to the second part of the journey. How will you find the time for the second part of the journey? Total time for the whole journey is 1.5. Time for the first half is just 1. So the time for the second half will be the difference between the two, 0.5. Next, we want speed for the second part of the journey. Distance divided by time. How much is the distance? 30. Time, how much? 0.5. 30 divided by 0.5 will give you 60 km per hour. There is a shortcut to do these questions. The average speed will be 2 times average speed for the first half of the journey times V2, the speed for the second half of the journey, divided by V1 plus V2. Now, another numerical. A car travels along a circular path with a radius 100 meters. And how much time the car takes to complete the whole journey? 62.8 seconds. And they wanted average velocity. To get the average velocity, we had to go for total displacement divided by total time. Since it came back to the same starting point, displacement will be 0. And average velocity will also be. Now, how do we find the average speed? Total distance divided by total time. Total distance is circumference of the circular path, which is 2 pi r, which will give you 2 pi r is 100 divided by time, 62.8. 10 meters per second. Thank you so much.